Hello guys, welcome to my channel Math Squad. So we have already seen fundamental theorem of arithmetic in the previous video. If you have not seen that yet, please go and check it out. So in this video we are seeing the examples which are given before exercise 1.2 in your textbook, NCERT textbook. So we'll see the first example. Consider the numbers 4 power n where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. So the question is, we are considering the numbers which are in the form of 4 power n. Okay. So we need to check, is there any number which ends with the digit 0 which is in the form of 4 power n. So many numbers will be there, no, which are in the form of 4 power n. Out of them, is there any number which ends with 0? The last number must be 0. The last digit must be 0. We need to check whether such a number exists or no. Okay. So considering the given number 4 power n, we can write it as 4. We can write it as 2 square. Of course, power n, where 2 power 2n. So this what does this mean? 2 into 2 into 2 into 2 into 2, 2n times. 2n times. Okay. The prime factorization of 4 power n is 2 into 2 into 2 into 2 into 2. That we understood. We need to understand this small thing. You probably know the divisibility rule of 5, right? So if any number must be divided by 5, so the last number should be either 0 or 5. Okay. That means if any number which has 0 in the end, it must be divisible by 5. So if our number has 0 in the last place, so it must be divisible by 5. Which means it has to be in the prime factorization of the given number. 5 has to be present in the prime factorization of given number. But 4 power n prime factorization has only 2's. There's no 5 in this prime factorization, right? We have seen here, okay? There's no 5. So obviously there cannot be a number which has 0 in last digit if it is in the form of 4 power n. So therefore there is no natural number n for which 4 power n ends with the digit 0. Okay. We are done with this question. Then coming to next question. Find the LCM and HCF of the numbers 6 and 20 by prime factorization method. Okay. First we will write the prime factorization of 6. 6 is equal to 2 into 3. Right. Only this much. Then prime factorization of the other number is 20. 20 we can write it as 2 into 10. Then again with 2 it will go 2 square into 5. Right? So here you have 2 power 1, 3 power 1, 2 square and 5 power 1 of course. 5 is a prime number, so we're ending it here. So to find HCF, what we need to do? Do you know how to find the highest common factor of the given two numbers using prime factorization? So the HCF of any number would be the product of the smallest power of each common prime factor in the numbers. Okay. HCF would be the product of common factors, common prime factors. Common prime factors means that prime factor should be present in both the numbers. Okay. And of course their product, and we need to consider the least power of the common prime factor. HCF, for HCF, we need to consider the common prime factor first thing and the least power of the common prime factor, and of course the product of all such common prime factors. So here we have common prime factor 2, here you have 2, here also you have 2, of course 2, and the least power would be 2 power 1, 2 square. So which is least? 2 power 1 is the least. So HCF of this is 2. There's no other common prime factor. No, here you have 3, but you don't have 3 here. Here you have 5, but you don't have 5 here. So the common number is only 2. And the least power is 1. So 2 power 1, 2. Coming to LCM, the LCM of any two numbers would be the product of greatest power of each prime factor involved in the numbers. For LCM, we need to consider every prime factor, not the common, but every prime factor, and the greatest power of the prime factor we need to consider, and of course product of all such numbers, right? So LCM here would be, here first I'm considering 2 excuse me. So the highest power would be here 2 power 1, here 2 square, the highest would be 2 square, and the product of, so it is like product of every prime factor, no? So the next prime factor we are considering 3, and the highest power of 3 is 1 only, and the next prime factor 5, the highest power of 5 is 1. So this thing would become 2 2 is 4, 4 3 is 12, and 12 5s are 60. This is the LCM. So for HCF, you need to consider common prime factor and the least power. For LCM, you need to consider every prime factor and greatest power. Okay, please remember, don't get confused here. And here you can see that HCF into LCM of the given numbers is 2 into 60. HCF into LCM is 2 into 60, which is 120. And what are the given numbers? 6 and 120. What is the product of 6 and 20? 6 into 20 is also equal to 120. Can you understand something from this? The product of HCF and LCM is equal to the product of the given numbers. So this thing which is highlighted here, HCF and LCM of any two numbers A and B is equal to the product of the two numbers given. Okay, so this is applicable for any two numbers, and we'll use this in solving the examples in the exercise. Okay, now we'll see the next example. Example 7. So find the HCF of the numbers 96 and 404 by prime factorization method, and hence find their LCM. Hence find their LCM means you need to use the whatever you have found till here, you need to use all that information and find the LCM, but not using prime factorization. Okay, first we'll see the prime factorization of 96. 96 is equal to 2 into 2 4s are 8, 2 8s are 16, then 2 square into 2 2s are 4, 2 4s are 8, then 2 cube into 2 1s are 2, 2 2s are 4, then 2 power 4 into 2 6 are 12, then 2 power 5 into 3. 3 is a prime number, so we need to stop it here. Next 404. 404, 2 into 2 2s 4, 0 and 2. Then 2 square into 2 1s are 2, 2 0, 0, 2 1s are 2. And 101 is a prime number. Okay, so you need to stop it here. What we need to find first? HCF, highest common factor. So the name itself you have common, no common. So we need to consider only common factors. What are common factors here and here? 2, of course. And we need to consider the least power of the common factor. Here you have 2 power 5, but here you have 2 square. So the least power would be 2 square. And yeah, that's it. 3 you have only here, and 101 you have only here. So HCF would be 4 only. Okay, HCF is 4. And next we need to find the LCM. Using this HCF, we need to find the LCM. How do we find? So we have learned that in the previous example, HCF into LCM is equal to the product of the given numbers A into B. Okay, so here HCF into LCM is equal to product of the given numbers is 96 into 404. Okay, here HCF we have 4, no? 4 into LCM is equal to 96 into 404. If I take this 4 here, it will become by 4, and if you solve this entirely, you will get 9696. Okay, this is the answer for LCM. We found LCM using the HCF and the given two numbers A and B, but not by the prime factorization. Okay, you need to Remember this also. This is also very important. Okay. Next question. Find the HCF and LCM of 6, 72 and 120 using prime factorization method. First, we'll find for 6 prime factorization. 6 of course 2 power 1 into 3 power 1. 72 we'll write 2 into 2 3 6 to 6 12. Then 2 square into 2 ones 2 eights. Then 2 cube into 9. Then 2 cube into 3 square. This is the prime factorization of 72. Now for 120, 2 into 6. Of course, 2 square into 30. Then 2 cube into 15. Then 2 cube into 3 into 5. That's it. Now we need to find HCF. So we know highest common factor is equal to, we need to consider only common factors. I can see that there is 2 here, here and here. So 2, and my least power would be 1 into next common factor is 3 and my least power is 1 here only. Okay. That's it. No other common prime factor. So 2 into 3 is 6. My HCF is 6. Now LCM. LCM is, we need to consider every prime factor in LCM. Okay. First number I will consider 2. The highest power of 2 is 3 here, 3 here. So highest is 2 cube into next number I will consider 3. 3 highest power 1, 2, 1. So highest power is 2 into next number 5. Highest power is 1 itself. So 2 cube is 8. 8 into 3 square is 9. 8 9 is 72. 72 5 is 360. So LCM is 360. HCF is 6 and LCM is 360. That's it. So that's it for today, guys. Now I'll see you in next video. In next video we'll solve exercise problems. Okay. For this video we'll stop it here. So until then, bye bye.